Hey guys, welcome to the Chapter 6 Population and Community Ecology math lesson. We're going to start with preparing to do the math, and this is going to be some graphing for us. We're going to graph some exponential growth. Alright, so it says you decide to invest $1,000 in a savings account. Your investment will grow at a rate of 10% each year. Assuming that you reinvest the interest each year, how much money will you have in 30 years? So that basically means that you have started with $1,000 in a bank account, and you've decided that every year when the bank gives you interest, which is kind of the bank's way of saying thank you for using our bank to hold your money, they give you this thing called interest. And so what they're going to assume is that you then reinvest that money. You don't take it out, you reinvest it every year for 30 years. All right, so the spreadsheet over here is going to give us all of the numbers that we're going to need to do this graph. It says here is a spreadsheet showing the growth of the investment. So we go from year 0 to year 30. And then it says graph the data and predict the year 30 information. And then it has a little note. It says a 10% return on an investment is very high. Currently, most banks will give you a savings account with an annual percentage rate of 1.5 to 3%. But for the purposes of our lesson today, we want to use a nice round number, so we're going to use 10%. All right? So the first thing that we want to do is we want to give our graph a title. Okay, so I'm going to call this graph exponential growth with a 10% return. All right? All right, now on my x-axis, I know that I'm going to want to do this in years. Okay, so my x-axis, I'm going to write years. And on my y-axis, I know that I'm going to want to do my investment. So if I turn it this way, I'm going to put my investment. Now, I don't really, since most of these numbers are in the thousands, I don't really want to write on my y-axis the thousands. So I'm going to put that this is, I'm going to use my unit as thousands.
Asha Clark to the front office. Asha Clark to the front office.
Okay, so I'm going to keep that as in thousands. All right, now on my graph, I can see that I have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 boxes, and I have 30 years. So in my calculator, I'm going to do 30 divided by 10, and that's going to give me my increment. So that's going to be 3. So I'm going to make my graph go by 3. So 0, 3, 6, 9, 12, 15, 18, 21, 24, 27, and 30. Alright? Now, in order to calculate my investment, I'm going to need my 30-year data. So down here, I only have the data for year number 29 and the interest. So what I'm going to do to find year 30 is going to be my my number from year 29, so $15,863.09 plus the interest, so $1,586.31, and that's going to give me $17,449.40. So I know I want my y-axis to go from 0 to 17,000. Okay, so if on my calculator again, I go from 17,000, and I know that I have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 again. That gives me 1.7 in increments, but I want to round up, so I'm just going to go ahead and use 2. Alright, so I'm going to have 2,000, 4,000, 6,000, 8,000, 10,000, 12, 14, 16, 18, 20. Alright, because I know that some people still struggle on what you're supposed to do with axes, and it's basically divide the difference between your minimum and your maximum divided by the number of increments you want to divide it into. Okay, now for the purposes of this lesson, I am just going to graph the numbers that are on each one of these guys. You will be expected to graph all of them. Okay, so what I'm going to do is I'm going to highlight them first. So 3, 6, 9, 12, 15, 18, 21, 24, 27, and then 30. Okay, so I'm going to graph those really quick on my graph. So at year 0, I know I have 1,000. Year 3, I have about 1331, so just a little bit higher. Year 6, I have 17, so a little bit higher, 1771. Year 9, I have 2357. It's going to be above this 2,000 line. Year 12, I have 3138. It's going to be a little higher. 15, I have 4177. It's going to be up here. Year 18, 5559. Okay, year 21, I have 7,400. Okay, way up here. Year 24, I have 9849. Way up here by 10,000. 27, I have 13,109. So 13,109. And then year 30, I have 17,449. So up here. Okay, now it'll be your responsibility to graph all of the extras and then draw a line through them. Your line will probably be more smooth than mine because you'll have more points, but this will give you the general description. Alright, and that's all we got to do for part 1. Hip hip hooray! Next, if we go down to the bottom of the page, it says preparing to do the math, doubling time, and the rule of 70. Okay, so we've seen this in case studies before, but this is just kind of a review. It's going to be very important. It actually is going to be one of those things that they will put on the test, so we need to be ready for that ASAP. Okay, so we have the doubling time, or rule of 70, is a useful tool for calculating the time it will take for a population or money to double. The rule of 70 explains the time periods involved in exponential growth at a constant rate. To find the approximate doubling time of a quantity growing at a given annual percentage, such as 10%, divide 70 by the percentage growth rate. Remember, the rule of 70 is an approximating. The actual rule is 69.3. So for our purposes, we are going to use the rule of 70. So we're going to divide 70 by the percentage growth rate. So in our example here, number 1 says the doubling time for the $1,000 investment with the annual percentage rate of 10%. So we want to know what is the doubling time. Okay, so doubling time equals 70 divided by the growth rate. Now this one's going to be another weird one, kind of like calculating our AP scores, which is going to be a whole number. Okay, so for our example here in the question, it says, what's the doubling time with the annual percentage rate of 10%? So it's going to be 70 divided by 10, or, that's an easy one, 7 years. Okay, and that's our answer. That's it. So we have 10% as a whole number, and we have 7 years as our doubling time. All right, let's turn it over. What's our next question? Our next question says that if a population of rabbits in an ecosystem grows at a rate of approximately 4% per year, the number of years required for the rabbit population to double is closest to, okay, so that's supposed to be closest. Okay, so this is going to be one of the answers for your WSQ. Okay, and so I'll see your answers then tomorrow. All right, so I gave you a practice problem. Now it's your turn. All right, next we're going to move on to our section, Do the Math Calculating Exponential Growth. Okay, so it says, consider a population of rabbits that has an initial population size of 10 individuals. Let's assume that the intrinsic rate of growth for a rabbit is R equals 0.5 or 50%, which means that each rabbit produces a net increase of 0.5 rabbits each year. With this information, we can predict the size of the rabbit population 1 year from now. Okay, so the intrinsic growth rate says that each pair, so an intrinsic growth rate of R equals 0.5 means that each set of rabbits has one baby. So each pair of rabbits has one baby, which means there's a 0.5 increase per rabbit. Okay, we know that that's not really realistic, but for the purposes of our question today, it's going to have to be. All right, so we're going to start with 10 individuals, n0 equals 10. Okay. All right, so what we're going to do is we are going to use this equation in order to answer our questions. Okay, so nt is our final population after it's been allowed to grow. Our n0 equals initial population, whatever we start with. R equals rate, and T equals time. Okay, so for our first one, okay, we're going to have NT equals NOERT. Now, E is one of those weird things where it's the button on your calculator again. Okay, so we'll talk about that in a second. So first we want to plug in the numbers that we use. So NO, our initial population, is 10 individuals, times e to the power of r times t. So r is 0.5 and time is 1 year. Okay, so we can simplify that even more. 10 times e to the 0.5. Okay, now if we get our handy calculator out, okay, we can see that, let's see if our button is here. It's actually the opposite of our natural log button. Okay, so I'm going to push second e to the x of 0.5, and that is 1.65 because I want to round. So 10 times 1.65. Okay, now it's really easy to do that on the calculator, and that gives us 16.5. So equals 16.5 rabbits. So that's how many rabbits are left over after 1 year. Okay, so that's how much the rabbit population has grown at a constant rate after 1 year. Okay, now our next question is, we can then ask how large the population will be after 5 years. Okay, so it's our same equation, we're just going to use 5 years. So I'm going to write the equation over here again so I don't forget. I always like to rewrite the equation. And I'm going to plug my numbers in. So NT equals, the NO is still 10 times E, and the rate is the same, but the time is going to be different. So the time is going to be 5 years. So that means 10 times E to the 2.5. Okay. Now on our calculator again, we're going to say, sorry about the glare, we're going to say second E to the 2.5 equals 12.18. Okay, so equals 10 times 12.18. If we do the simple math there, that gives us 121.8 rabbits. So you can see that these are growing quite quickly. Okay, so if we look at this graph here, we can see that after 1 year, we still don't have very many, but after 5 years, it started to rise. And then you guys are going to calculate this one for your WSQ, and it's probably going to be somewhere up here. Okay, so you need to determine what that is. All right. Alright, now you're going to change the growth rate. Now assume the intrinsic rate of growth is 1.0 for rabbits. Calculate the predicted size of the rabbit population after 1, 5, and 10 years. So you're going to do the same thing, only your intrinsic rate is going to grow. So I'm going to set up this first one for you and then let you go on your own. 10 times e to the 1.0 times 1. Okay, so this is for 1 year. You're going to do for 5 years, and you're going to do for 10 years. Okay, just like before. All right, I have full confidence in your abilities. Now, last part is going to be the measuring your impact. What you're going to do is you are going to graph this information. Okay, it can be on notebook paper or Excel or whatever you want to do. You're going to graph the changes in the Living Planet Index over time for each of the 5 regions. So you should have a line for each one of these. 1 line for each. So 1, 2, 3, 4, 5 lines total. Okay. Globally, which region of the world has experienced the greatest decline in biodiversity? You'll be able to see that with your graph. Overall, has the decline been greater in temperate or tropical areas? So you're going to need to compare the temperate and tropical areas. Okay, marine doesn't really count for this one. And then the last question is, the World Wildlife Fund attributes the decline of biodiversity to habitat destruction, overharvesting, and pollution. Based on the above data, identify 3 actions that individuals could take to slow the decline of species richness. So that's going to be on your WSQ form again as well. All right? And that's it for today. I'll see you tomorrow.